So good afternoon, everyone. So you're very welcome to UCD's Institute of Food and Health Research Bites. It is the last one of 2022. It's going to be delivered today by Roisin O'Sullivan, and Roisin is a final year PhD student in the School of Agriculture and Food Science. And her PhD is in the area of using analytical techniques of stable isotope ratio analysis to underpin the country of origin and grass feeding claims on dairy products. And she's doing a PhD as part of the Food for Health Ireland project. Roisin recently spent 6 months in the US working with a venture capital firm as a technical official overseeing the supply chain and ingredient technology investment portfolio. And indeed, this trip to the US was sponsored by the Institute of Food and Health as part of our aim to increase the entrepreneurial spirit and the sense of innovativeness within our PhD students. So over to you, Roisin, to share with us your research experiences. And thanks very much for doing this.
Thanks, Dolores. I suppose I don't have to introduce myself now. My supervisors are Frank Monaghan and Olaf Schmidt. So I think Olaf is here, but yeah, so I'll talk through in two parts my research first of all, and talk about stable isotope ratio analysis and how it's been used to understand diet and geographic effects in dairy products specifically, so that we can underpin those claims, and then some method development work that we've done. And then I'll talk about my venture capital role and a little bit about what I did when I was in the venture capital firm and the importance of it in supporting research like ours. So to start off the research part, I'd say everyone who's on the call here is aware of how Irish dairy products are marketed. You know, we're known for our luscious green fields with animals out to pasture for, you know, the vast majority of the year. And that's really attractive to consumers who want to make their food purchases based on the environmental and those animal welfare, you know, implications of those food purchases. But how can we scientifically underpin those claims? Can we prove that consumers are able to trust in the claims that are on those dairy products to be able to make those food purchasing decisions? Well, one of the methods that can be used is stable isotope ratio analysis. So to briefly talk about how stable isotope ratio analysis works, for example, if you take a milk product, you wanted to analyze the carbon, nitrogen, sulfur, oxygen, and hydrogen stable isotope ratios on that milk sample. You'd prepare it and put it through an isotope ratio mass spectrometer, which works in a similar way to a regular mass spectrometer, but the difference is that you have this collector on the bottom, and the collector measures the relative abundance of the different isotopes, so that you're able to get a ratio of the heavy to light isotopes, which you then compare with a reference sample so that you can standardize, and you're able to measure different isotope ratio values. And they'll tell you different things about a product, about the background of a product. So number one, if we're looking at delta 13C, so carbon stable isotope ratio values, that will provide information about the dietary background of the milk producing animal. So different plants have different photosynthetic pathways and will discriminate between carbon isotopes in a different way. So by looking at those delta 13C values, you can tell a lot about the diet of the milk producing animal. Then if we looked at delta 15N values, this is related to agricultural practices. So again, to do with the diet of that milk producing animal, whether the animal ate grass that had been artificially or organically fertilized, you'll be able to notice a difference in those delta 15N values and underpin those kind of claims as well. Then if we look at delta 34S values, so sulfur values, that provides information on the geographic location of where the milk producing animal was. And that's related to the geology of an area. So different countries will have different geological makeups, which will influence those delta 34S values, and also to do with proximity to the sea. So there's a sulfur sea spray effect. So if the milk producing animal was raised close to the coastline, you could tell the difference between that and one that was raised further inland. And then finally, if we look at delta 18O and delta 2H values, these values are related to geographic origin as well in terms of precipitation stable isotope values. And those values will differ depending on different longitude and different latitudinal coordinates. So that's an overview of what stabilized hope ratio analysis is and what we can kind of tell with those stabilized hope ratio values. So what we did was we wanted to look at the effect of diet on different stabilized hope ratio values, and we looked at Irish milk. So we took milk samples from 50 farmers in the middle and south of Ireland, and we created these 4 different dietary levels. So highly grass-fed being less than 500 kilograms of concentrate or grain input per hectare per year. And then a highly grain or concentrate fed diet was greater than 1,000 kilograms of concentrate per hectare per year. And we conducted stabilized hope ratio analysis, looking specifically at carbon, nitrogen, sulfur, and oxygen to see, can we tell the difference between these different dietary levels in the Irish milk samples. And you can see from our principal component analysis that there's a good differentiation between our highly grass-fed in green and our highly concentrate-fed in blue samples, and a bit more of a spattering between the middle dietary levels. But when we actually put some statistical analysis to the test here, we were able to see that diet effect was statistically significant for the carbon, nitrogen, and sulfur stabilized hope values. So you can kind of see how we're able to differentiate between a highly grain-fed or a highly grass-fed milk sample, and how that could be used to underpin those grass-fed claims on milk products. We then took to the literature to compare stabilized hope signatures between different countries. So we looked at different papers that had analysed milk samples from different countries. And you can see that the delta 13C values here were quite different between the Irish and the Chinese samples, and less different between the US and the Australian, New Zealand samples. Then if we look at delta 15N, the Irish and the Australian, New Zealand samples were more similar, and the China and the US samples were more similar but different from the other two. Then if we look at the more underreported delta 34S values, there's a huge difference here between the Irish and the Australian, New Zealand samples. And then finally, delta 18O, you can see a difference in all 3 countries, with the most negative being US, followed by China, and then Ireland. So you're starting to see how we can build up this stable isotope signature for each country, and that it's going to be quite different depending on what country the actual product came from. But what I want to point out here is that I've separated the milk casein values from the values that were measured on milk water. And that's because you wouldn't be able to compare delta 18O values that were measured on milk casein with those values that were measured on milk water, because the values will be based because of that compositional difference rather than any of these grass feeding or geographical differences. So our next step was to think about how we could apply this analytical method to dairy products. So we all know that dairy products are very complex food matrices. You know, but a piece of butter would be very different in terms of its composition and its fat content compared to some whole milk powder. We also know that protein and lipids isotope ratio values differ substantially. So those compositional differences would be in effect, and you wouldn't be able to compare those 2 products based on the geographic or grass-fed differences, because the differences would be due to composition. So what we wanted to do then was see, could we make inter and intra product comparisons based on using a common constituent to all dairy products, which was casein. So we took to the literature and we looked at casein isolation methods that were specifically used to prepare samples for stabilized hope ratio analysis. And we found these 3 methods for cheese, whole milk powder, and butter. And we found that there were 3 common steps in all of these methods: a lipid extraction with or without a solvent, casein isolation at the isoelectric pH, and then freeze drying. So what we were able to do was verify that published cheese casein isolation method. We were able to prove that we got a pure casein isolate from that sample. And for the other 2, we found that we needed an additional solvent lipid extraction with a different solvent that was used earlier to get a pure casein isolate from that. And I'll go through the results now. So each sample of casein that was isolated underwent elemental, protein, and stabilized isotope analysis. And I have the results here. So you can see that for our 2 published methods for whole milk powder and and butter, we got a C to N ratio, carbon to nitrogen ratio of around 7, and a protein percentage of between 40 and 50%. Now we know that high purity casein would have a carbon to nitrogen ratio of around 3.5 because we analysed a purchased pure casein sample, and a high protein percentage because it is a protein. So these values didn't match up. But when we added in that additional solvent lipid extraction for those two methods, we were able to see that, sorry, there should be a little graphic appearing there, but the C to N ratio was reduced to around 3.5 for both of these cases. And then the protein percentage was much higher. And it was in line with what we got for the cheddar cheese casein isolation. There we go. And then if we look over to our stable isotope results for the delta 13C and delta 2H values, you can see that we got around -28 and then in and around -160, -180 for carbon and hydrogen. And we know from the literature that less negative delta 13C and delta 2H values are consistent with a lower lipid content. So as you can see again, when we added in that additional solvent extraction step, we were able to get a less negative delta 13C value and delta 2H value for that whole milk powder and butter casein isolation. So you can see that we were able to verify that published cheddar cheese casein isolation method. And for our whole milk powder and our butter casein isolation methods, we were able to enhance that published method to remove that extra bit of contaminating lipid that was remaining and get a more pure casein that could be used to compare and contrast within different dairy products. This is just some bit of a case study, some preliminary data to kind of show how this method can be applied using Irish farmhouse cheese. So we got cheese samples from different farmhouse cheesemakers around Ireland. You can see it's a very small sample size. So we have 5 samples from Cork, 2 from Waterford and 4 from Galway. But I've just put this up here so you can see that even the slight differences between the geographic locations can be picked up using this method. It's a really precise method. So you can see for the hydrogen and oxygen values here between Cork and Waterford, the values are quite similar. But when we look up to Galway, you can see that there's a slight difference in these values. And then if we look to sulfur, the sulfur values for Galway and Waterford are quite similar, and they're a bit different for these Cork samples. So being able to detect these slight differences is really useful for specialty products. So protected designation of origin and protected geographical indication claims are already well known in the EU and are used on Parmesan cheese, for example. So you can see how this method has the potential to be used to underpin those claims as well, and how it could be applied to different Irish farmhouse cheeses. So that's a bit about my research. I'll go on to talk a little bit about the venture capital experience that I had now. So first of all, to talk about what exactly a venture capital firm is, because I didn't have a clue when I was first going over. You generally have a venture capitalist who has a vested interest in a specific topic or area that they want to invest money in, and they are usually quite knowledgeable about that area. And then you'll have investors. They could be high net worth individuals, they could be a family office, and those people are interested in investing their money in a similar area to what the venture capitalist is. So what they do is they all put their money into one big venture capital fund. And these funds can vary in size depending on what the venture capital company is, like what size it is and what level of a company they want to invest in. And then they hire investment associates. So that's where I was within the company. I was an investment associate. And what we did was we evaluated startup companies to decide where that investment, that capital fund was distributed out to. So we evaluated different startup companies and made a decision based on our own kind of experience and that of the higher up people in the company, whether to invest in a startup company or not. So I always say that it's a little bit like Dragon's Den, because that's how I would describe it to any of my family members when they asked me what I was doing over there. It's literally you sitting in the chair asking the startup company to tell you about their business and their market opportunity. And then you would have an investment portfolio based on all of the companies that you invest in. So each venture capital firm will have a very different investment portfolio. And it's really important that they invest in the right companies. First of all, to make their capital back on the company, but then also because the type of company that they invest in will become their reputation as a company. And whether more investors will put more money into the fund. And that's how that kind of business will grow further and further, and they'll be able to invest more. So my role in the venture capital firm was a supply chain investment associate, which was loosely, I think, connected to my work as it's kind of traceability and proving claims of country of origin for products. So I was put on the supply chain investment associate, and my main role was in 3 different parts. So it was sourcing, evaluating, and doing research and due diligence on startup companies. So sourcing involved a lot of cold calling and networking within the venture capital firm and within different venture capital firms, and also within academic circles. So I was really thrown in the deep end, being told, find a startup company that you think we could possibly invest in. And it took a lot of talking to people, reaching out, and a lot of my own research to find companies that I thought would be beneficial for us to actually meet with. And that was the next step of my job then, was to meet with the startup companies. And then I had a scorecard where I would score the companies. So that was based on their team. So who was making up their team and what their experience was, the market opportunity for their product or their company, their business plan, their future business plan and current business plan, the competition in the area, any traction that they had so far, and also the deal terms. So whether they had a really high valuation that was not really meeting with what we would usually invest in, or whether they were on a completely different, like who was already invested in them, and whether we would be able to work alongside them. And then the third part was research and diligence. So when I had met with a startup company, I would get a good idea of whether we might invest in them or not. And then after that, I would do a lot of research into that particular area, because I was given lots of different topics to kind of specialize in. So we also had different specialists that we would get in from UC Davis, from the community and network that my fund already had, and ask them questions about the company and what their thoughts were, what the market was, and whether they would be a good investment for us. So just some of the different areas that I was kind of told to specialize in: alternative dairy and ingredient technology, which is something that, will be quite comfortable with as a food scientist; traceability and transparency, which ranged from AI and software as a service, like advanced, looking at different kind of softwares that could have been used to analyze data historically and be used to predict future sales in a restaurant, for example, or being able to analyze whether, so for example, there was one company where they were looking at restaurant waste, and they had created this data, this software there. You could put in all of the sales that you had over the particular weeks, and then make a prediction as to what you would sell in the next coming weeks. And that way you could buy only what you needed. And that would be how you would be able to reduce your food waste in the restaurant. And then there was also pathogen detection and different kind of on the farm technologies that I was involved in assessing. So some of my learnings, there's just a few photos there from my time. The diligence process, so being able to understand how to evaluate a startup company, was something that I really valued being able to learn. Talking the VC talk, it's very different to talk to business people and startups and CEOs and people who had been in the industry for years and years and suddenly decided to start a startup company, from talking to other PhD students and academics. Then also startup financing. So whether, we all know that research grants need to be applied for and gotten, but it's very different from getting a research grant to getting startup financing. And there are lots of different levels to it, depending on how far along you are with the technology. There's also different types of VC firms, which I kind of spoke about, and how they raise their funds. So there could be a family office where they have family funds that they use every year. But then there are other firms like my own that needed to make sure that they had investors that would give them money every year to be able to actually invest. Then one of the most important things was probably the importance of venture maths. So understanding, if you invest X amount of money at this stage of fundraising of a startup company, would you in 10 years' time make that money back and make a profit on it? Even if there's dilution with other investors coming in to invest in the company, understanding whether the market opportunity that you saw when you first invested in the company is still going to be there in 10 years. It's something that is very mathematical and actually quite scientific, but ultimately you're still making a guess. But venture maths was something that was really interesting to me. And then obviously the ability to speak about lots of different unfamiliar topics and technology. I really was thrown in the deep end there. So these are just some photos from a trip to UC Davis here with some of our portfolio company CEOs and some of the investors, and then some academics from UC Davis that we worked with. And then this was my team down here at FTW Ventures. So I just wanted to finish off with a slide that was shown at every conference talk, every kind of meeting that we had over there about how important venture capital funding and financing is in supporting research. So you obviously have here the invention stage. So this is where you're applying for your research grants. You know, you're looking for that funding, you're being really inventive, thinking of ideas to be able to get that money in to start off with. And then you conduct the research. So this is where we all come in as PhD students and we're working on a particular idea, and maybe a few papers get published, but ultimately it ends up that the research comes into this valley of death, very dramatic analogy that was used. And what they were talking about was how we need to be able to get over that, build that bridge over the valley of death into commercial application, so that we're able to get research out of the lab and out of being published into journals and actually out to be used in the real world and in industry. So it's that funding and that kind of advice that people within this area are able to give to academics that can really produce that. And you're starting to see how it's being done these days. You know, Food for Health Ireland, who fund my research, are really useful at being able to kind of spot areas that could potentially be commercialized. But it's trying to get over this valley of death here. And that's where the venture capital funding comes into play in supporting our research. So thank you for listening. Sorry if it was a bit long, just going through the research and the business, but I'm happy to answer any questions that you have for me.